Hello, everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to go a little bit deeper into the wonderful world of inodes. Now, inodes, as we'll see, have a wealth of metadata. So this can be extremely useful to us as we try to examine a system and try to figure out what happened. So we're going to start with the simplest case, and that is with a standard inode that is 128 bytes long. And this is something you would find in an ext2 or ext3 system. Now, if you have an ext4 system, they will use 156 bytes, although their size on the disk is 256 bytes. And this allows for some future expansion. This way, if they add a couple of fields to the inode, you don't suddenly have to resize every file system to use the new features. So first of all, let's talk a little bit about finding an inode. How do I find where my inode lives? Well, the first thing I need to do is I need to figure out what is its block group. And to figure out the block group, all you need to do is take your inode number minus 1 and divide that by the number of inodes per group. It's pretty simple. Now, why do we subtract 1? We subtract 1 because inode 0 is undefined. We start our numbering at 1, and that makes the math a little bit weird, but if you want to see weird, you should deal with Microsoft file systems, and you'll see that they have all kinds of weirdness where sometimes things start with 1, sometimes 0, sometimes 2. So once you've figured out which group, then you need to know the index within that group in order to find the correct inode in the table. And that is just that same number, the inode number minus 1, modulus the inodes per group. So your offset into the inode table is then just that index times the inode size. Now, when I say the inode size, I mean its size on disk, not its actual size if there's some padding, as is the case with ext4. So what does this inode look like anyway? It has all kinds of information in there. It starts out with a file mode, then the user ID that owns it, its size, its access, change, and modify and delete times if it's been deleted, its group ID, its hard link count. We don't care about symbolic links here. We just need to know hard links so that when the last hard link's been removed, we can delete the file. How many blocks are used by this inode? Recall that the inode is everything you wanted to know about the file except for its name. Any kinds of flags. There's also several unions that are operating system dependent, and for the most part you'll encounter ones with the Linux version, and if you were creating this file system with Linux, it would give you a version for your inode in that spot. And then you have the block pointers. There are 15 of these. They're each 4 bytes. We talked about these briefly before. We have the first 12 that point to data blocks directly, and then we have some indirect pointers as well. We'll talk more about those in detail later. Then we have the version. We also have the access control list if it's being used, the extended attributes, which are typically ACLs, but as we'll see, they can be other things. the file size, the upper 32 bits of the size, if it's an ext4 file system only. There's an obsolete fragment address, and then there is the second operating system dependent structure. In it, you see things such as the blocks, the upper 16 bits, file ACL, again, upper 16 bits, same thing with user ID and group ID. And then there's a checksum for your inode. Following that, we have the extra size. The extra size says, all right, a standard inode would have ended right now. So the first 2 bytes, we say how much additional storage is used in this inode. Then we have a checksum, and we have change, modify, and access times. And then here is something new. Now remember that only ext4 file systems might have these extra parts of an inode, but we have something that we haven't had before, and that something is a file create time. And then we have the create time extra bits as well. We'll talk about how to decode those in a future video. And then we have the version and unused space. So that's kind of our generic inode. Now there are a couple of special purpose inodes. First of all, inode 0, as we already said, does not exist. Inode 1 has a list of defective blocks. 2 is the root directory. 3 and 4 are user and group quotas. And 5 often contains the bootloader. 6, an undelete directory if it's being used. 7 is used for reserved group descriptors. Recall from some earlier discussions that you can reserve group descriptors for resizing a file system. 8 is something pretty important. It's the journal for a journaling file system, assuming it's not external. And then 9 is an exclude inode if you're doing snapshots. 10, replica inode. And 11 is typically the first non-reserved inode. And most often, what you will find there is the lost and found directory. So that's a lot of information. And we will, in future videos, we'll show you how you can get all this information out of the inodes. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon.